So there's a lot of information, but the key point is to figure out how to process the data. So then let me go be a little bit more detailed about these different signals. First, cardiorespiratory signals. So this is acceleration data. So let's look at this acceleration data. What do you see here? Just guess. What do you see here? What is this wave?
That'd be the respiration.
Oh, that's the respiration. Okay. And what are those little spikes? Heartbeats. Yeah, exactly. So, and then you can zoom in. So this is data from an infant. So you will see, let's look at the black traces here. You see, these little peaks. These are heartbeats, and these little peaks are always followed by a small peak, a big peak, small peak, big peak, small peak. So the big peak is heart sound 1, S1. The second peak is S2, heart sound 2. So this indicates the closures of different heart valves. So, this is actually very well studied in cardiology. So when different valves of your heart open or close, they generate acoustic signals, and we can capture those signals, and we can use those to diagnose disease. So here we are capturing S1 and S2. And, this is actually respiration. But, for heartbeat signals, you can just use like peak finding to, to identify these peaks and calculate heart rate. And respiration is much more difficult. So because when you move around, you introduce motion artifacts. So, calculating heart rate, respiration rate during movement is very difficult. It's not something very well adjusted in current wearables. Even in research preference, it's still a challenge here. Okay, then we also have vocal signals like singing, speaking. And singing, speaking is generated essentially by the vibration of your vocal fold. So your vocal fold vibrates, and that oscillates your air, and that creates vocal acoustic signals.